So welcome everybody to today's presentation on integrating MongoDB into your existing developer workflows at any stage of development. But first, how many of you have been to the MoMA in New York City? I know we're in San Francisco. Okay, awesome, great. I'm glad that some of you have. If you haven't been before, highly recommend paying a visit. I hope you like it as much as the MoMA here in SF, and I'm a huge fan of modern art. They have a great collection there, and in our demo today, we're actually going to be building a MoMA application together, looking at artworks in the New York City MoMA Museum. Alongside our appreciation for modern art at MongoDB, we understand two things very well. One, AI is raising the bar for how quickly software must adapt to market expectations. But software can only evolve as fast as its foundation allows. And two, accelerating a developer's pace of innovation is the key to helping a business unlock potential to scale and meet those evolving expectations. And that all starts with the database. At MongoDB, we've always put developer experience at the front and center, because a great developer experience is what allows developer to move fast. Tools and integrations are a fundamental component of the developer experience. So today, we're going to explore the tools and integrations that MongoDB provides to streamline the development process. Our focus will be on demonstrating how these tools fit seamlessly into your daily workflow, enhancing productivity and automating repetitive tasks, freeing you up to focus on more important things like innovation. So let's dive into how MongoDB's developer tools can be valuable assets in your own developer toolkit. Imagine this scenario. I just joined a new project, and to familiarize myself with the code and the team's processes, I'm working on a new feature. The project consists of a web application to discover and search through artworks collected at the Museum of Modern Art in New York City. And these are collected in a MongoDB database in Atlas. In the current implementation, users of the application are able to see all of the artifacts available at the museum, and we're also experimenting with searching through them using both full-text search and semantic search. So let's go through the process of contributing to this application together. I'll start with defining the portion of the developer's experience that we'll look at together. As a developer, I want to start coding as quickly as possible without wasting a lot of time in setting up my laptop and my dev environment. So we'll look at how that's really easy to do with MongoDB. And once I'm ready to code, I want my toolchain to integrate nicely with my IDE, so I don't have to jump back and forth between windows and tools. So we'll look at what MongoDB integrations are available directly in your IDE and how to best take advantage of them. Once my code is ready to go, like all good developers, I made sure that my code is well covered with tests. And I want to make sure that my and my teammates' pull requests are validated and tested thoroughly before they get merged and pushed to production. And that's easy to troubleshoot with MongoDB. So we'll look at what MongoDB has to offer for that. To run this application on my laptop for development, we'll need to do a little bit of setup. First, we'll need a local MongoDB cluster. You're probably wondering, why do we need a local MongoDB cluster? Well, it provides the best sandbox environment. A local cluster provides a safe space for experimentation without impacting live systems in a controlled setting. It also enables rapid iteration and debugging to test and validate local changes with no network latency, which is able to enhance the quality of the applications we build. All in all, having a fast local setup is about accelerating the development cycle and improving overall productivity. So what else do we need? We said our application allows for users to search through the museum's collection with full-text search and semantic search. So our local cluster needs to be able to do both of these with Atlas search. And we also need to include Atlas vector search to develop our semantic search use cases. And of course, it's hard to develop and test our application without any test data, so we'll need that too. But how difficult is all of this to set up? It's actually incredibly easy, and this is how it works interactively. All you need to do is type Atlas deployment setup in your terminal and hit enter, and in just a few seconds, you get a local Atlas cluster up and running and ready to go with the Atlas CLI. Luckily, there's also a programmatic way, which makes automating this pretty easy. So let's take a look together, and we will switch to the demo to look at how we can set that up programmatically. Awesome. So now we're looking at VS Code here, and you can see that the engineer who set up this project already wrote this init script for us. And here, we're calling that exact command that I was just talking about. here you can see that we are setting up our local cluster. We're defining the version of MongoDB that we want it to be using. And we're also calling this initDB script that's written to seed our test data. So everything is already ready to go programmatically. And we could run it here live, but I already ran it this morning because it takes a while to seed the test data. So we're just going to go ahead and start looking at the data to make sure everything is set up correctly before we move to actually writing the code together. Before I do that, how many of you have used MongoDB Compass before? OK, if you look around, that's actually most of the people in the room. That's awesome. So Compass is our most popular developer tool. And as you know, it makes it really easy to visualize your data and interact with it. So we're going to check out our test data here in Compass together. Now that we're here, I'm also going to announce that today we are really excited to announce the general availability of the MongoDB Assistant in both Compass and the Atlas Data Explorer. So we're going to take a look at all of our test data that's already seeded using the Assistant, which is available up here in the top right corner of Compass. The Assistant is actually built using Atlas with a RAG cluster that also uses Atlas Search. So this is kind of a meta demo if you understand what's going on. Here you can see that we have this announcement that with this general availability of the Assistant, we also released tools. And these tools make it possible for you to talk to your data using the same tools that are accessible in our MCP server directly in Compass and Data Explorer. It's possible for you to disable them if you want by looking at this tools toggle here. You can turn them off or on, and they're only read-only for now. So there's no write permissions here, and it's possible for you to confirm every tool before it is executed. So we're going to go ahead and ask for an overview of the data. So now it wants to run the list databases tool, and it's asking us to confirm. It will always ask for you to confirm a pending operation so that you can trust the actions that are being performed by the assistant. And here we can see all of the databases. Great. I'm going to also ask for the schema. It's looking at our current collection associated with this tab here. Awesome. And it's showing us our schema here as well. If you had any questions that you wanted it to answer by running a find query or an aggregation, it would also be able to do that for you directly here in the chat to make it easy for you to navigate your data where you're doing your work in Compass and writing your queries. Awesome. So now that we've taken a look at Compass, we're going to go back to the slides, and we're going to talk a little bit about this next stage of development. OK, awesome. Now that we have our environment set up and our test data seeded, we'll need to write some code together and see what tools are available in the IDE to help us all work more productively with MongoDB. According to the most recent Stack Overflow survey, 84% of developers take advantage of AI when they write code. And half of professional developers expect that over the course of this year, AI will be even more integrated into the process of writing code. These numbers make a lot of sense, and I think all of us agree with this sentiment. AI has the potential to drastically improve the developer experience and help developers move faster. That's why we've integrated MongoDB for VS Code, our first-party VS Code extension used by over 2.2 million developers with Copilot. With this integration, we make accessing MongoDB documentation, getting insights on your collection, schema, and your data, generating queries and translating them into your favorite programming language extremely easy. And you can also use the MongoDB MCP Server in VS Code with Copilot. The MongoDB MCP Server gives your agentic developer tools like Copilot in VS Code, Claude, Windsurf, pick your IDE of choice, the ability to intelligently automate and optimize data workflows with MongoDB. It's now possible to explore schemas, deconstruct complex tasks, optimize indexes, and even perform Atlas administrative actions without any manual effort. And we just saw some of those tools in action in Compass as well. So let's switch back to the demo, and we're going to start looking at Copilot in VS Code together again. Great. So, could we switch back to the demo, please? Awesome. Thank you so much. Cool. So I've already configured the MCP server here in Copilot for us so that we don't have to do the setup together. And you can see that Copilot is running in agent mode down here too, which gives it access to all of the MCP tools. So let's go ahead and just ask it a question about our data to see how the MongoDB MCP server integrates here. I'm going to ask it, how many artists have artwork in my cluster? It's already connected using the MongoDB VS Code extension, but you can also configure this connection directly in your MCP settings configuration. OK. It looks like it tried to connect to an old cluster that I had set up first, but now it's looking at the cluster that's connected over here. Great. It's able to figure that out on its own. And now we can see that we have just over 1,000 distinct artists with artwork in our collection. You can see that it listed databases, collections, and it ran an aggregation command as well to figure out that answer for us. Great. So that's an example of how the MCP server can work here in VS Code with us, for us. So now that we have explored our data a little bit more using the MCP server, we're going to take a look at our code and see how we can fill out this method here in this class using the MCP server and the VS Code extension. This method is meant to make it easy for us to get artworks by department and artist, and you can see that there's this little to-do mentioned here. So to get started with implementing this method, I'm going to go back to Copilot, and I am going to ask it to help us write this query by running an example of what this might look like in action. I'm going to ask it to find artwork by artist Otto Wagner in department architecture and design. Great. It ran the find query for us. That looks correct. And it's giving us some examples of responses here. Oh, it looks like Copilot also noticed that we have this method here that has a to-do comment, and it's asking us if we want it to implement the method for us with a similar filter query. I'm going to say, yes, please. I love it when Copilot does your work for you. Great. OK, you can see that this generated code matches the exact syntax that we have elsewhere in the file, using filters and also returning a Mongo cursor, which is exactly what we want. So using the MCP server and Copilot, we just tested our query and implemented it in, what was that, less than 20 seconds? It's pretty awesome. Cool. OK, so now that we've written our method, we are going to switch back to the slides, and we're going to talk a little bit more about this next stage of development. So now to get this into our code base, all we have to do is put up our pull request, and then also somebody on the team is going to take a look, and we're going to run some extra tests and just confirm that everything is working as expected, so that when it's in production, we're confident in how the query is going to perform. So we're going to see how MongoDB tooling integrates in that process. We'll start with taking a look at what that pull request actually looks like when it's submitted to GitHub. You'll see here that when the PR was submitted, 2 workflows were triggered, one for unit and integration tests, and one with end-to-end tests. I'm going to walk you through how this is set up, and more specifically, how to take advantage of MongoDB tools in a GitHub action. For unit and integration tests, everything there happens locally. All the dependencies, including the database, run within the workflow. And this is convenient because GitHub makes it very easy to orchestrate, and because running everything locally means shorter feedback loops. So let's go through how that's configured in the unit integration tests YAML file. Service containers are a feature of GitHub Actions to run services needed to test or operate an application in a workflow. For example, in our case, we need to run integration tests that require access to a MongoDB database, and having a local database makes the tests run a lot faster. The same considerations we discussed earlier for the local development environment all apply here. This code snippet shows how, within a workflow in GitHub Actions, you can create a service that provides a local MongoDB database with Atlas Search and also with Atlas Vector Search. What this means in practice is that the local experience for Atlas is also available in Docker and Docker Compose. So if your entire development workflow is based on Docker, you have the option of using this Docker image directly too. OK, here's our pull request again. And if we look at the results of our workflows, we can see that all is good on the unit and integration test front. Yay! But unfortunately, the end-to-end test failed. So let's dive into that and see if we can understand what's going on. From the log, it looks like the method, or the test for the new method that we wrote, is actually the test that's failing. And that's because it's taking too long. It's also worth noting that our end-to-end tests run against our staging cluster in Atlas, not our local cluster. So there might be something going on with latency or with having more data that the test runs against. So let's go see if we can figure that out together and go back to the demo. Great. So now we're going to be looking at the Atlas console. And if you've interacted with Data Explorer in the Atlas UI before, you'll notice that something is different in this UI here. And Data Explorer now provides a much more comprehensive experience for visually interacting with your data and to troubleshoot your queries and aggregations, as we're about to do. If you're familiar with Compass, you'll feel right at home now in the Atlas UI looking at Data Explorer. And today, this new experience is generally available for all users. So let's go ahead and recreate our query that we just wrote together here in Data Explorer. I actually was running this earlier today, so I'm just going to use the recent history here. But if you wanted, you could generate the query with natural language, or you could use the MongoDB assistant up here to help you do the same thing. OK, so I just ran the query, and I am noticing that we have this light bulb insight pop up here. And it says that our query was executed without an index. Queries executed without indexes are a little bit slower, and if you expect to run queries frequently in your application, you'll want to create an index to make sure that your query is performant. And we can actually use the MongoDB assistant here to help us understand whether or not we want to create an index and weigh the pros and cons of that. So clicking Tell Me More takes us back to the assistant here and gives us some trade-offs and benefits for creating this index. So if you have a question about whether or not it's the right decision for you, you can always go back to the MongoDB assistant to get expert guidance, and it is informed with all of the best information that MongoDB has to offer. Awesome. So if we went ahead and created this index and pushed that to production, our end-to-end test would pass, and everything would be good to go to production. MongoDB always has your back. We detect potential issues and suggest improvements early in the development process, but we also help you figure out if something has gone wrong and how you can address that issue. And in this particular case, if you're a forgetful person and you forget to create an index and end up pushing something to production, MongoDB Atlas Performance Advisor will catch it for you and notify you of your missing index. So if we can go back to the slides for the wrap-up. Great. So now we're just going to do a quick recap of everything we've looked at together today. And we're going to summarize the developer workflow experience here and how MongoDB's tools support you across your journey. So first, we looked at using the Atlas CLI to quickly get set up, configure our development environment, and prepare our local development cluster. We also explored looking at our test data using Compass's intelligent assistant and the MongoDB MCP server with Copilot and VS Code. Second, we dove into writing applications to speak to MongoDB, and we prototyped a query with the MCP server and the MongoDB extension in VS Code. And third, we validated our query's functionality through automated testing to ensure our application works as expected in various scenarios, including a remote staging environment. We saw how MongoDB seamlessly integrates testing workflows with local Atlas environments in Docker, and we used the new enhanced Atlas Data Explorer to analyze exactly how our query was not performing the way that we expected it to after we noticed that end-to-end test failure. And we made the query more efficient as well. And throughout this whole workflow, we harnessed the power of AI in MongoDB's intelligent developer tools to accelerate our productivity and gain deeper insights into our database and queries. With MongoDB's tools, we truly support developers at every stage, from setup to coding to testing and optimization, ensuring a streamlined and productive development experience. I encourage you all to go and try out these tools if you haven't before on your own and see how you can improve your own productivity building with MongoDB. Our MoMA application really just starts to get into it and touches the tip of the iceberg with what you could do with MongoDB's developer tools. Thank you so much for attending this talk, and feel free to find me after if you have any questions. Thanks.